A university's mathematics department has 10 professors and will offer 20 different courses next semester. Each professor will be assigned to teach exactly 2 of the courses, and each course will have exactly 1 professor assigned to teach it. Okay. If any professor can be assigned to teach any course, how many different complete assignments of the 10 professors of the 20 courses are possible? Okay, so to understand, to translate the word problem into a combinatorial thing here, I have a list of 20 objects. Which are the courses, and I have a list of 10 professors. So I basically have to match things like this and think of how many possible ways I can do that. I could think of this as, each professor is given a color, and how many ways are there of distributing 10 colors across the 20 courses such that each color appears exactly twice. Okay, so how do I want to, or I wonder if there's like an alternative way of thinking about this where I think of the 10 professors as being down here. I don't think so. I think this is a better way of doing it. Okay, so I've got 20 objects. Let's think about distributing the courses to each professor one at a time. So the first professor, how many different possible assignments can he get, he or she? Well, it's going to be 20, choose 2. You walk into the head of the department, and the head of the department is going to give you your course distribution for that year. There's 20 courses, you're teaching 2. This is the total number of combinations that you could possibly get. Second professor walks in, and the number of courses left is 18, and they also have to choose 2. And so on. You can see then that the total number of combinations is going to be 20 choose, we're just going to multiply these together. 20 choose 2, 18 choose 2, 16 choose 2, all the way down to 4 choose 2, and 2 choose 2. Okay, now is there some kind of fancy way of expanding this? I mean, we're given a bunch of options. It's a multiple choice question, of course, and I suspect the answer might be E, just because it has a 2 to the power of 10 in the denominator and still quite a large number in the numerator. But let's write this all out. 20 factorial times 18 factorial, 16 factorial. A lot of these are going to cancel out. 4 factorial, 2 factorial, divided by 2 to the power of 10, because the 2 factorial appears 10 times. But then I also have 18 factorial. That comes from the first term. 16 factorial, 14 factorial. This gives me a 2 factorial, and this gives me a 0 factorial, which is 1. So of course a lot of these are canceling out. So maybe the answer is not E. In fact, it appears to be A. Okay, so everything cancels. And we're just left with 20 factorial divided by 2 to the power of 10. And that's option A. Yeah. I mean, I think this type of discrete mathematics combinatorial stuff really is not my strength. But this seems to be exactly how you would do it. I mean, let's assume we only had 10 courses instead of 20. The typical way you think of this is, you know, one professor gets assigned one course. There's 10 ways of doing that. The second professor gets assigned the next course. There's 9 ways of doing that. The next professor walks in. There's 8 ways of doing that. And you just multiply all those numbers together. You don't have to, you know, that way of doing it takes into account maybe you assign the courses to the professors in a different order. You know, instead of the first professor getting assigned a course first, maybe the fourth professor is the first one to get assigned a course. But that doesn't matter because that's already taken into account. It's just a different ordering. So here, like the vision that I had in my mind is basically the same thing. First professor walks into the office. They get assigned 2 courses. How many ways are there of doing that? It's 20, choose 2. Second professor walks in. How many ways are there to assign this professor another course? It's 18, choose 2. And so on. And then just multiply them all together. You don't have to worry about the professors being assigned courses in a different order because that different ordering is already, their actual course assignments are already counted in the first way of solving this. Okay, so that's my answer. I hope I didn't make any silly mistakes on this one. Ended up being, usually this type of combinatorial stuff, I guess you could say intimidates me a little bit. I usually need to think about them for a really long time, but this one seemed to be pretty straightforward. Thanks for watching.